What if you spent just 5 hours on a distant planet, but when you came back to Earth, 50 years had gone by? Friends who were your age just a few hours earlier now look 50 years older. Your little children who were only 5 years old just hours earlier are now fully grown adults. It sounds like science fiction, a plot from an epic blockbuster. But what if I told you this isn't just a story? It's a fundamental, mind-bending reality of our universe, a principle known as time dilation. So, how can a few hours become 50 years? According to Einstein, the flow of time is controlled by two things: speed and gravity. Change either one, and you change the rate at which time passes. The faster you move, the more slowly time passes for you compared with someone standing still. But Einstein discovered there's another way to slow it down. What if you approached one of the most extreme objects in the universe, a black hole? There, gravity becomes so strong that it curves space-time itself. According to Einstein's general theory of relativity, stronger gravity causes time to pass more slowly. As a result, a clock near a black hole runs much more slowly than an identical clock far away. For every second we spend near its event horizon, a century could vanish on Earth. But this raises an important question. If time dilation is real, why don't we notice it in our everyday lives? After all, we're constantly moving, and we're constantly surrounded by Earth's gravity. The answer is simple. In our everyday lives, the effects of time dilation are so incredibly small that they're impossible to notice. Whether you're walking, driving a car, or even flying in an aeroplane, your speed is tiny compared with the speed of light, and Earth's gravity isn't strong enough to produce any noticeable difference in the passage of time. However, when an object travels at a speed comparable to the speed of light, time dilation becomes significant. This naturally leads to an even more fascinating question. What would happen if an object could actually travel at the speed of light? According to Albert Einstein's special theory of relativity, no object with mass can ever reach the speed of light because it would require an infinite amount of energy. Only light, which has no rest mass, can travel at the speed of light. According to relativity, if an object could travel at the speed of light, time would completely stop for it. Fortunately, or unfortunately, that is impossible for anything with mass. Time dilation isn't just a fascinating scientific idea, it's something we rely on every single day. For example, GPS satellites orbit Earth at very high speeds. Because they're moving so fast, time passes slightly more slowly for the clocks on board than it does for clocks on Earth. The difference is tiny, only a few microseconds each day, but GPS systems require incredible precision. If scientists didn't correct for this effect, it would quickly become inaccurate. Within minutes, your location could be wrong, and the error would continue growing every day. In other words, without Einstein's theory of relativity, modern GPS simply wouldn't work. Time dilation plays an important role in medical imaging. The high-speed particles produced during this technique follow Einstein's theory of special relativity. Accurate predictions of their energy and motion help doctors create detailed images of organs and detect diseases such as cancer at an early stage. So, the next time someone tells you that Einstein's theory of relativity is just an abstract idea, remember this. From GPS navigation and medical imaging to particle accelerators, relativity is quietly working behind the scenes every single day. Time dilation isn't just science fiction, it's part of the modern world we live in.